Good morning. This recording is for Algebra 1, Chapter 6, Lesson 2, Solving by Substitution. Substitution, in my opinion, is one of the most elegant math things out there as far as, algebra, linear algebra, it goes, It's very simplistic, it's very easy, it's very math heavy. Anyway, I think it's very elegant. All right, moving on. All right, there are multiple ways of solving systems of linear equations. This is going to be one of them. There's going to be at least 2 or 3 more for you to do besides graphing. All right, so the substitution method replaces one variable with an equivalent expression containing the other variable to make a one-variable equation that you can solve. You have already done this before with the perimeter problem, where it says the length of a rectangle is 3 times the width, or 8 more than 3 times the width, and then the width, they don't tell you what the width is, and then the perimeter would be like 64, and then you have to figure out what the width and the length are based on that information. So you have already done this before. This is not something new, but obviously we're going to go over it again. Just because it hasn't formally been taught. You've done the concept before, you just haven't formally been taught it. Okay, so when you have 2 variables, you need 2 equations to solve. And when you have 2 equations, especially linear ones, you have a system of linear equations. So let's say we have these 2 equations. We have y equals 2x and 7x minus y equals 15. So basically, because y equals y in both equations, because they are a system, and x equals x in both equations, they are interchangeable. I can swap them around. Also, wherever y is, since y equals 2x, I can substitute the letter y with 2x, because they're equivalent. Since they're equivalent, it'd be like, all right, well, I need a black sock, but I don't have the black sock that I know I purchased with this other black sock, but I have a different black sock that I can use. The black socks are the same thing. Obviously one's charcoal and one's gray, or one's charcoal and one's black. They're not equivalent, but these are equivalent. They're just different black socks, which means if I need a black sock, it doesn't matter which black sock I grab. The only thing is in math, we can only solve for one variable in one equation. So we need to get the same variable into the same equation with the other same variable. So here's what we're going to do. If y equals 2x, I can replace where I see y here with what I know y equals. In this case, 2x. Okay? So 7x minus 2x equals 15. I now have one variable, one equation. Let's go ahead and solve for x. All right. So 7x minus 2x is 5x. 5x equals 15. Divide by 5 on both sides. X equals 3. Now that I know what x is, I can plug x back into either one of my equations, either the y equals 2x or the 7x minus y equals 15, and figure out what y is. All right, now you know x, solve for y, plug it into one of the equations to determine y. I'm going to plug it into y equals 2x, so y equals 2 times 3, which means y equals 6. All right, that's great, Miss TH. Now what? What does this mean? Well, you can put it into a coordinate form, which you should. Your answer should be as a coordinate point with the x and then the y in parentheses, okay? And then this is your solution. Yesterday I taught you, or the day before, depending on when you watched videos, depending on class, whatever, I told you that the solution to a system of linear equations is the point at which the 2 lines intersect. Well, guess what, guys? This is the point. If you were to graph these 2 equations, the point 3, 6 is where these 2 lines would intersect. All right? So that's the solution. This is just a way of figuring out that point without actually having to graph. Okay? I know I showed you an early easy way to graph using the app, but this is how you can do it mathematically. All right? Especially if you are forced to pen and paper, and graphing means that you're going to have maybe fractions or something crazy that you just really don't want to graph. this is how you can do it mathematically without having to graph. All right. So let's go ahead and look at another problem. We have 3y plus 2x equals 4 and negative 6x plus y equals negative 7. And we need to get a variable by itself. We either need to get x by itself or y by itself. Now, unfortunately, all the example problems I have today, it was more convenient to get y by itself. But it doesn't mean you don't have to get x by itself and use x equals something in your substitution. It is completely up to you. And if you'd like me to show you some problems in class, just go ahead and ask, and I will show you some problems where getting x by itself either may be more convenient, or you can just go that route. You know, even if it's not convenient, you can waste your time, or not necessarily waste your time, but you know, you can go the inconvenient route if you so choose. Okay, so let's do some substitution by first getting something by itself. I'm going to get y by itself, and I think I'm going to go with the green equation over there on the left. And so I'm going to add 6x on both sides, which gets y by itself. Y equals 6x plus negative 7. I'm going to replace y over there with that part of my equations. So I now have 3 times 6x plus negative 7 plus 2x equals 4. Distribute. I'm going to get 18x plus 21 plus 2x equals 4. Combine like terms. That's 20x plus negative 21 equals 4. I'm going to solve for x, add 21 on both sides. That would be the addition property of equality, by the way. That's the addition property of equality, is adding something on the same on both sides. And then I'm going to use the division property of equality to move the 20 over, and x equals 5/4, which is the same as 1.25, and I'm just going to leave it as the decimals. You got a calculator. When you can turn it to a decimal, do it, but sometimes it is convenient to leave it as a fraction because you don't want to have to go through and get some irrational numbers going on when it's just easier to leave it as a fraction. Okay, but now that I know what x is, I can replace x over here. See that little red arrow? It's not very little, it's pretty long actually. And then we're going to replace x with 1.25. Negative 6 times 1.25 plus y equals negative 7. Solve for y. Y equals 0.5. So the solution for this system of linear equations is 1.25. 0.5. That is the point on the graph where these two lines intersect. And again, I don't want to have to graph those nasty decimals. Right. So mathematically, you can figure it out and just have the calculator handle the decimals. All right, next slide is 6y plus 8x equals 28, and we have 3 equal to x minus y. Again, I solved for y. You could have solved for x easily and gotten, your answer would have still been the same if you'd done your math correctly. So it honestly doesn't matter if you solve for x or y or which variable you get by itself. It's just sometimes there's one that's more convenient to get to. Okay, so y equals 2x minus 3. Going to plug that in for y. We're going to distribute. Woohoo, I did a lot of math there. Make sure I did it correctly. All right, so a lot of math there. And then we got to combine like terms. We're going to move over the 18. We're going to get 20x equals 46 and solve for x, and x equals 2.3. Again, finding 2.3 on a graph by hand, not fun. But doing mathematically, kind of easy. All right, so now that we know x, we're going to plug it back in, and honestly, it doesn't matter. You could have plugged it into the equation over here. You could have plugged it into that one if you so desired. I just like to mix it up some. I was like, oh, I already did a lot of math with that problem on the left, so let me stick it back into the problem on the right. It's up to you. You should still get the same answer. But yeah, I just like to mix it up a little. Okay, so let's plug it into 2.3 for x. We're going to get 3 equals 2 times 2.3 minus y. Solve for y. Y equals 1.6. 1.6. So the actual solution is 2.3, 1.6. That's the point where this line and that line intersect. Okay, all right. Let's go ahead and do a word problem. Your school must transport 193 people to compete to a competition. There are 8 drivers available and 2 types of vehicles. The school buses seat 51 people each, and the minivans seat 8 people each. How many buses and vans, that's vans, will be needed? All right, so we need at least 2 equations to have a system. You can obviously have a system that has more than 2 equations, so it has to have at least 2 to be a system. But since we need 2 equations, at least, we need at least 2 variables. Well, here are my 2 variables, buses and minivans. We need to figure out how many we need of each. So, the number of vehicles is going to be the first equation I'm going to write. Well, we know that the number of buses plus the number of minivans has to equal the number of drivers I have. I have 8 drivers, so the number of buses plus the number of minivans equals 8, because I need 8 people to drive those vehicles. Next thing up is the number of people. If I know that 51 people fit in a bus, 51 times the number of buses is going to tell me how many people are riding in the buses. And 8 is the number of people that can fit in a minivan, so 8 times the number of minivans will tell me how many people are riding in the minivans. Altogether, though, this should equal 193 people. I'm assuming that we're not counting the drivers, but we're not going to get into that. We'll just assume 193. Normally the bus driver doesn't go to the place, or the minivan driver doesn't normally go to the place, but whatever, we're just going to assume that doesn't count. Okay? All right, so now that I have 2 equations and 2 variables, I can solve. Yep. Okay, so let's go ahead and get a variable by itself. I'm going to get m by itself this time, so m equals 8 minus b. I'm going to plug in 8 minus b into my equation down below. And I'm going to get 51b plus 8 times 8 minus b equals 193. Distribute 51b plus 64 minus 8b equals 193. And basically, we're going to continue to get b by itself. And we're going to get b equals 3. Pretty cool, huh? So how many buses do we need? We need 3 buses. Now we're going to plug in my 3 buses back into that first equation up there. And we're going to have 3 plus m equals 8. M equals 5. So that means we need 3 buses and 5 minivans, which makes sense because we only had 8 people to drive those 8 vehicles. All right, last one. Softball team played 149 games. The team won 8 more games than 2 times the number of games they lost. How many games did they lose? Well, W is going to be the number of wins. L is going to be the number of losses. 2 variables, 2 equations. So the first equation is going to be the total number of games. It should be the wins plus the losses. Because if they tied, well, I guess they never tied. They didn't tell us they tied. They just told us they won 149 games, and they either won or they lost. No ties in this situation. Okay, so that's the total number of games, and the second equation is going to be comparing wins to losses. So the wins is equal to 2 times the losses plus 8. Okay, so now, since W is already by itself, I can already go ahead and plug in 2L plus 8 in for W. So I'm going to have 2L plus 8 plus L equals 149, combine like terms. And we have 3L plus 8 equals 149. I'm going to minus 8 on both sides. Again, that was the subtraction property of equality. And then I'm going to divide both sides by 3. And I'm going to get the losses equals 47 games. So out of 149 games, they lost 47 of them. That's not bad. That's not bad at all. All right, I'm done. Thank you for listening. Bye.